In this video, we're going to talk about supplemental examples from 9.2, where we talked about convergence and divergence of series and some of our first tests for convergence and divergence. Let's do one by definition first, where we find the sequence of partial sums S1, S2, S3, S4, and S5 for the given series here. S1 is going to be equal to 3. S2 is going to be 3 minus 9 halves. Go ahead and use your calculator. That's negative 1.5. S3 is 3 minus 9 halves plus 27 fourths. Again, use your calculator. That's 5.25. S4 is going to be 3 minus 9 halves plus 27 fourths minus 81 over 8. It's going to be negative 4.875. And S5 is going to be 3 minus 9 halves plus 27 fourths minus 81 eighths plus 246 over 16 is equal to 10.3125. I think you can see that this is alternating back and forth, but it's not going towards any particular number here. It's going to diverge. So let's verify that this series diverges. Easiest thing to try here is the nth term test for divergence. That equals 1, which is not equal to 0. So it fails the nth term test. I'll just say it diverges by the nth term test. Which the nth term test is theorem 9.9 in our textbook. Let's verify that the infinite series converges. Hint, use partial fractions. So we have n equals 1 to infinity. A over n plus b over n plus 1 is going to be equals 1 to infinity. A n plus a plus b n over n times n plus 1. So a plus b, the n parts, need to equal 0, and a, the constant part, needs to equal 1. That means b needs to be a negative 1, making this n equals 1 to infinity, 1 over n minus 1 over n plus 1. And let's write out the first few pairs here. 1 over 1 is 1 minus 1 over 2, and 1 over 2 minus 1 over 3. And that pattern continues until I get to 1 over n minus 1 over n plus 1. And that will cancel with that with this next part, and this with the previous part, leaving me with s is equal to the limit n goes to infinity of the nth partial sums is equal to the limit as n goes to infinity of 1 minus 1 over n plus 1 is equal to 1 minus 0 is 1. Let's find the sum of the convergent series here that is geometric. So remember, for a geometric series, S is equal to a sub 0 over 1 minus r, where it's written in the form of summation of n equals 0 to infinity, a sub naught r to the n. This has to be the absolute value of r is less than 1 for that to work. And it is here. 2/3 is less than 1, so it's going to converge. And it's going to converge to 5 over 1 minus 2/3. It's 5 over 1/3 multiplied by 3 over 3, and we get 15 over 1. S is equal to 15. Now let's find the sum of this convergent series. So we're going to use partial fractions once again. N equals 1 to infinity of a over 2n plus 1 plus b over 2n plus 3 is going to be equal to n equals 1 to infinity, a times 2n plus 3 plus b times 2n plus 1 over 2n plus 1 times 2n plus 3. So 2an plus 3a plus 2bn plus b needs to be equal to 0n plus 1. So 2a plus 2b equals 0, which is the same thing as a plus b equals 0. And 3a plus b is equal to 1. So a is equal to negative b. So negative 3b plus b is 1. Negative 2b is 1. B is equal to a negative 1/2. And a and b have to be opposites here, so a has to be a negative 1/2 is a positive 1/2. So that makes, let's pull out the common factor of 1/2 in front of this series. So this is 1/2 n equals 1 to infinity of 1 over 2n plus 1 minus 1 over 2n plus 3. And that's going to be 1/2 times, and starting with 1, 2 plus 1 is 3. 2 plus 3 is 5. Plus 2 times 2 is 4, plus 1 is 5, minus 4 plus 3 is 7. And we see the pattern here. So keep that going to 1 over 2n plus 1 minus 1 over 2n plus 3. Close that up. So that one will cancel with that one, and that one with that one, and this one with this one. And s is going to be the limit as n goes to infinity. S sub n is equal to the limit as n goes to infinity of 1/2 times 1/3 minus 1 over 2n plus 3 is 1/2 times 1/3 minus 0. So 1/2 times 1/3 is 1/6. All right, and that's everything for this video. And we'll come back next time and talk about supplemental examples from 9.3. See you for the next video.